Hello everybody, today I want to explain about the structure and evolution of the stars. Let me share my screen. Yes. In horizontal branch stars, we have helium core burning, carbon and oxygen in center builds up. Helium intershells and hydrogen burning shell and envelope, as you see here. Production of carbon-12 and oxygen-16 until helium in the core is exhausted. Horizontal branch starts to asymptotic giant branch. Core temperature too low for carbon or oxygen ignite. When helium is exhausted, core begins to contract, releasing gravitational potential energy, increasing the fusion rates in the helium and hydrogen fusion shells. Atmosphere expands and temperature decreases, and red giant reaches the asymptotic giant branch or AGB phase. And you see here the asymptotic giant branch. These are the stars that we have hydrogen, helium, and carbon in core. But the core is not dense enough, that is burning. But around it, we have helium shell, and which is burning, and in top of it, there is hydrogen shell burning, as you see. Also, you see here, core is the size of the Earth, and convection in the enlarged portion of envelope. And this is the Earth's orbit. And central region of the HV stars, helium fusion shell, carbon-oxygen core, that in asymptotic giant branch, it is not dense enough, that is burning, core is not burning. And at last we have dormant hydrogen fusion shell, that is also not burning. Asymptotic giant branch, convection in large portion of envelope, heavier elements formed in the star's interior mixed secondary dry job, strong stellar wind, a large radiation pressure drives stellar wind, particles absorb photons from radiation field and be accelerated out of the gravitational potential. Interstellar medium enriched with mostly carbon, but also oxygen and nitrogen. Thermal pulses, which means mixing the atmosphere because of different shell burning phases, and material is going outside and is expelled into the interstellar medium. And this is in some point we can see as a planetary nebula. The hydrogen burning shell adds mass to the helium-rich region between the burning shell. In the internal intershell region increases the pressure and temperature at the bottom of this region. When the mass of the intershell region reaches a critical value, helium is ignited in an unstable manner called a helium shell flash. The large energy flux drives convection in the whole intershell region. Intershell convection zone, at last mixing. Thermal pulses is a large energy release expansion of the intershell region. Helium burning shell expands and cools down, time scale of about 1 year. A hydrogen burning shell extinguishes the penetration of the outer convection envelope. Convection can even penetrate beyond the now extinct hydrogen burning shell. Material from the intershell region is mixed into the outer envelope. Third dredge up and helium burning and hydrogen burning shell and line phase of stable hydrogen shell burning follows. Mass of the intershell region grows until the next thermal pulse. The duration of this interpulse period depends on the core mass, lasting between 50,000 years, less than 1,000 years for the most massive AGB stars. And also in here we can say that after first dredge up, which means the complete star is mixed from deepest core to the atmosphere, we have a helium shell. At the end of the AGB or asymptotic giant branch stars phase, we have the second dredge up, and then through the thermal pulses, the model shows that there is the third dredge up. Here you see the planetary nebula. During helium shell flashes ejection of outer atmosphere regions. And the question is, why planetary nebula looks different? The most important reason is the magnetic field and then binary possibility. If we see a planetary nebula which is quite symmetry, then it is normally a single star like this. For example, our sun will be like this or this or this. But if it is not symmetry and has disk jet like this, as you see, yes, and if we see a planetary nebula and that is not symmetry and has disk jet, it is a binary system. And we can see the planetary nebula in ultraviolet. Planetary nebula expands at a speed around 20 km/s, radius of about 1 parsec in 50,000 years. The driving force is the radiation pressure caused by intense ultraviolet emission from the central core acting upon dust grains in the nebula. Dust grains condense out from the cooling nebula gas because of the existence of heavy elements such as carbon. Here you see the time scales. We can see that life of stars is first main sequence, then subgiant, then RGB or red giant branch, then horizontal branch or HB, and then asymptotic giant branch or AGB, and then at last planetary nebula or PNE. And we can say in helium flash, the complete star is mixed. In red giant branch or RGB stars, we have helium burning core and hydrogen burning shell. Here you see the age of the sun, billions of stars, and here is luminosity of the sun. You see the different age of the sun. For example, sun is an AGB star after during the time, and you see the different evolution of sun or solar star like sun. The other stars that are like sun. And thank you for your attention. See you next time. Bye.